Okay, so now we have our odd and our even degrees. So if I have an odd and an even, their ends are going to go opposite direction. So this will make more sense with examples. So we're going to jump right into some examples. Okay, so we're going to refer back to this though. So make sure again you have this filled out, but we're going to do examples on the next page. Identify the end behavior of the function. Remember, the end behavior starts the same. We need to do as f of x, oopsies, as x, I'm sorry, approaches infinity, f of x approaches blank, and we're just filling out the blank. You need to write all of this though, but it looks the same, except we fill in our answer there. That's the right-hand side, and we need to do the left-hand side. As x approaches negative infinity, f of x approaches blank. Okay, so we are going to be, as x approaches positive infinity, f of x approaches, well, let's see. We have here, this is what we're working with, and I'm not going to go and graph this. I'm not, because I can tell what's going on by the leading coefficient and the degree. So this is in the correct order, so that's good. And then, so my leading coefficient is going to be -2. So I'm going to write that off here. My leading coefficient is -2. And my degree is going to be the exponent, remember. The exponent, the largest exponent is 7. So the degree is 7. Well, let's see what I know about that in terms of my chart. My leading coefficient being a -2, that's negative. And then my degree being 7, that's odd. So what do I know about negative and odd? Let's go look at my chart. A negative but odd degree, when those two meet, will take me to here. Negative means my right side of my graph goes down. So if I were to draw a rough sketch, my right side of my graph would go down. And odd means they do opposite things. So that means my left side's going to go up. Okay, so I didn't graph this, but I know that as x approaches infinity, f of x, well, that means as the right side of my graph is going down towards negative infinity. Okay, and as x approaches negative infinity, which means as x goes to the left, my graph is going forever up towards positive infinity. And that matches what's happening here. Every time you have an odd degree and a negative exponent, your end behavior is always this here in the chart. Okay, now let's do this example. It's in the correct order. And so I'm going to have a leading coefficient, oopsies, LC equals 3. My degree is 6. Well, what do I know about that? My leading coefficient being 3, I want to know if that's positive or negative, and that's positive. 6 is even. That's what I want to know about my degree. And so I know that if I have a positive leading coefficient and an even degree, let's go find that one on my chart. Positive leading coefficient and an even degree means my answer is going to be coming from this top left-hand box. Alrighty, so that means that I know that my graph, since my leading coefficient is positive, my right end is going to go up. My right end's going to go up. I'm not sure what it looks like in the middle. And then since my degree is even, that means the ends are going to look the same. So my left side is also going to go up. So if I were to write now I can write my end behavior, right? So as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x also approaches negative or positive infinity because they are the same. They are going both up forever to infinity, the right and the left.